But I only do this if wheels are touching. Oh, wait, you know what I should actually do? I should apply opposing force of the wheel. So this applies forward force. I should actually apply a sideways force as a negative friction. So then it can actually, like, flip the car, potentially. I'm just thinking, do I just actually add these together? Like, is applying... Could I maybe just add these together? Alright, so what this'll do now, this actually might bug out if body velocity is negative. So I think I need to scale this by the friction, or yeah, by the velocity. And then to also make this proper based off delta time, I'm actually going to need to feed this through POW. I'm just thinking how this dot product will work. So if the direction is equal to the friction, then there is friction. Yeah, that actually is how it should work. Oh wait, maybe this should actually be applied as an impulse. Ah, so that's the difference. I think it's using its mass. No, velocity change is what we're going for. I'm just thinking, I actually, no, never mind, I need the sign from this dot product to flip the friction around if necessary. So how am I gonna scale this? So I think it's mathf.pow. We do this, and then the delta time. Oh, this should actually be fixed update too. Is this how it's supposed to work? So this is a multiplier, but I'm actually scaling the friction. Huh. So actually, I don't think I scale this. I think I do mathf.pow fixed delta time. So if this is 1, this won't change anything. Maybe it's actually supposed to be the other way around. No, I think I'm misunderstanding this. So if, say, I want the friction to add up to 100% over 60 frames, it would need to be 1 divided by 60. Oh my god, am I literally just looking for times delta time? I think I am. Yeah, I think I can just do force plus equal friction. And then I just need to multiply friction by, I don't know. Maybe by the delta time? Huh. Let's see how this works. Let's see if this adds friction. Okay, I'm gonna debug. Doesn't seem to be working that well. Let me think about this. Debugging actually is still not as good as actually taking the time to think about what's happening. So now move X is actually forward, so when it's forward we flip the vector to the right. Now when we're going to the left and right we move it to the forward. So then that isn't necessarily actually in the direction of this. So if the body velocity is equal to the friction direction, okay, this should actually be negative. So that way if it's the same direction, the friction goes negative. What is happening? Okay, so going forward makes me spin around now. And the sideways buttons don't make me spin. That's not good. So that's with no friction. Maybe I should add a way to turn it off. Off and on so I can debug it. So thinking about this, if it's moving sideways, the friction is forward. And then if that doesn't match up, it ends up flipping it to negative. Huh. I guess I'll turn this down. Alright, still seems to be very slidey. Going forward actually goes forward though now. Oh, it actually kind of spins out now, which is good. I guess it is showing a little bit of friction. I should probably increase the quality of these, the light. So what if I turn it up? Okay, so that's weird. It causes sort of a counteracting effect. Or when you go straight, it actually makes you spin. Huh. So I guess the force not being equal to the friction. Oh, wait, I'm dumb. This is supposed to be scaled by the body velocity. So let's try this now with full friction. Oh god. Seems to kind of have the same effect. Going forward causes it to go sideways. Huh. I guess I'll scale it down a little bit and see how that works. Yeah, it's so weird how going straight pushes it sideways. I guess it makes sense though if the direction is forward. Oh my god, am I stuck? Huh, it's not registering the wheels as touching. I wonder if I raised them a little bit. Oh, it moved a little bit and then got stuck again. Huh. I guess I could maybe just scale down the force. Huh. But that would not have the same effect as applying force at a position. I wonder if there's also something better I can do here. Oh my god, whenever it goes here, it gets stuck for whatever reason. Why is that? No, that's not a good system of doing it.
seconds we're about to float. It's sinking or swimming, thinking of you in the afterglow. But I still believe that we are only going through the motions, If we could turn the tides, got 4 or 5 seconds and we're out of time. It only takes 4 or 5 seconds, we're about to float. It's sinking or swimming, thinking of you.
I guess maybe I'll try applying these separately. That actually does seem to work a little bit differently. No, that's still got issues. The way it kind of like spins around like that is really bad. So I'm thinking what I'm gonna do is I'm gonna multiply down the velocity. But the issue is it's like, to make it proper I would have to apply it where it collides. I'm almost thinking of doing a system where I like store forward velocity. So right now what I'm doing is I'm not using any of the friction from the PhysX or built-in physics. I'm trying to simulate friction myself and then use the regular physics to basically move forward. What I'm thinking of actually doing now is shifting it the other way around and using physics to do all the friction and everything, and then keep track of some movement or like forward thing. Basically like how much the wheels are spinning and how much velocity there is pushing forward when the wheels have friction. And then that basically fights against the friction.
Do you feel alive?
I guess I can also just generally apply this.
In the darkness, we all have to fight. Lost children and silhouettes and raving against the blackest night. Hatred. Do you even know the meaning of the word? And sometimes in the silence, I ask myself, do you feel alive? And sometimes in the silence, something grows. I don't know if I mentioned it. Keep thinking now, somehow. Okay, now we dive. Don't put your delay on me. Fuck your auto-tune. Dramatic ones and twos. I have grain. I have grit. Nitty-gritty. I have
Alright.
darkness.
Now how do I scale this
Witty.
based off delta time. How do I make it so right now what this will do is this will scale velocity down to 0 when it's going the other direction of the force. But then I can't remember, how would I make this change? Let's say it cuts off half the velocity over a second. That would be mathfpal 0.5f time.fixed delta time, right? This fixed delta time would be small, it would scale up that and then make it slower, I believe. Alright, so applying that logic here, I like the idea of just being able to drift just by holding the side button. But it has no side friction right now, so it's not working. It is not working. Oh, interesting. Ah, so it was applying the friction even when the car isn't moving. Doesn't seem to be applying here. Yeah, it doesn't seem to be applying. I guess because that's angular velocity. So that's the complicated thing, is how would I clamp the angular velocity depending on, like, how would I convert? I guess I can actually determine that because the wheels are on pivot points, that when there's angular velocity they will be moving in certain ways. So I guess I can just do this same thing to angular velocity. The angular velocity vector of the rigid body measured in radians per second. Now, How is this in Euler angles? Do they actually use Euler angles for this? In most cases, you should not modify this, as this can result in unrealistic behavior.
Talk a lot, but can it? Hack it, sending it for 6 off the planet. I was measuring the distance till it vanished. A pessimistic vision made me panic, but lessons of the wisdom save the malice. Above the average, mission elevate the masses. Listen to your intuition, separate the assets. Land full of wonders, name it Alice. Resonating shanties or a palace. They talk a lot, but can it? Hack it.
Is indeed the rotation axis normalized multiplied by rotation speed. Gives what rotation angle is. So to get the angle. Okay, nice. I'm glad someone's able to describe that. So we'll have our friction multiplier.
Hack it. Lucid when I'm dreaming on the mattress. Groove for no reason around the atlas. Got uni demons booming it on campus. Soon to see the unity attack us. The love will catch us. Realign your chakras. But something tells me that this generation might be active.
Alright, let's try that.
Steady through the chapters. See, we're never going backwards. They talk a lot, but can it? Hack it.
Oh, it kind of seems to be stopping. That's weird. It seems to be slowing itself down now. No, it's not functioning. Maybe I am looking for a wheel collider. Let's look at Unity's wheel collider. Yeah, sideways and forward friction is what I need. Alright, let's look up how to use Wheel Collider. Alright, let's follow this Unity Wheel Collider tutorial. I'm just gonna go get some water and then we'll do this. Alright, so you manually set torque. I just automatically started reading this. It actually looks really simple, and I kind of thought, from what I remembered, the Wheel Collider was kind of buggy before when I used it, so hopefully this will work well. Alright, just gonna get water and then we'll do that. Alright, so my one issue with this is I want to be able to detect sliding sideways and drifting so that I can do effects during that. And I actually don't think the Wheel Collider gives me that. Maybe they have events for that. Let's look up. How can I instantiate and play a sound when the Wheel Collider is slipping? You can use wheel hit, sideways slip, and forward slip. They specify the slip amount to start playing sound. Wheel hit. Friction for the Wheel Collider is computed separately. Oh, nice. Okay, so we can access the slipping direction. That is really nice. Alright, I guess we're going to manually add our wheels. And I guess I'll just end up basically deleting this script then. So let's look at the wheel tutorial. Add the wheels, change the name to wheels. Create the wheels, duplicate. To make the car actually drivable, you need to write a controller for it. Axle info. Motor torque, steer angle. Alright, I think I've got it. I'm just gonna switch my wheels over to these. So actually, I want to test what happens with one wheel. Oh God, what happened? What is happening? Why does this start out flying? Is it because of the Wheel Collider? Yeah, what is going on here? Huh. So I guess maybe the wheels can't be touching the bigger collider. What is going on? Why does this start out just like flying around? Rigid body. Too light for default suspension settings. Interesting. So what would I change the spring to? What if I set it to 1? Still sends it flying. Huh. Weird. So I'm just gonna mess around with this for a second. So that seems kind of buggy. Like, why are the wheels just shaking? Hold on, I gotta Google this. Unity wheel collider shaking. I guess it's because the wheels aren't equal. Okay, that's pretty good. That is pretty good. Man, I'm almost thinking that going through the issues with this wheel system might be more difficult than just doing it myself. It seems like it's working okay, but it is just constantly pushing the car backwards. I don't really like that. Yeah, it's just constantly pushing the cart backwards. So, hold on, let me see something. If I align these all and do 4 wheels. Does it still go backwards? Yeah, I feel like Unity's built-in wheels are pretty buggy. Yeah, I can't see any reason why this would be uneven like this. Like, what is going on here? I don't know. So this is kind of why I don't want to use Unity's built-in wheel collider, dealing with bugs like this that don't really make sense. I don't know what I can do about this wheel collider thing. I think I'm just gonna go back to the old system. Alright, so I got some ideas on how to make friction here work instead of just doing multiplication, or instead of just scaling it down. I think I need to, well, I know what I need to do. I need to apply sideways force. And see, the other thing is I need to apply this to the, what's it called, to each wheel, which actually depends on the angular velocity in a way. So I guess I could calculate the angular velocity. Yeah, I'm just thinking how I would take angular velocity into account. I might need to do it for each wheel here. Hello, 97 Guten. What are you prepping for? I'm just trying to make a little car in Unity. I tried to use wheel colliders, but the car glitched out and got like stuck. So now I'm just using a box collider and I'm trying to implement friction myself, and as you can see, it's kind of buggy. trying to just simulate a car's movements using just a box. Right now it's a very slidey box, basically. Like moderations, what do you mean? Moderating your own stuff. I guess. I might visualize the wheels here with gizmos. Just so I can see where the wheels are. Want to know what I work as? Sure. Karate master teacher, oh my god. Not expecting that. What is a karate master? Is that like a black belt or? There we go, now I can kind of see white lines showing the wheel ray casts. Alright, so how would I calculate the movement of the angular velocity? I'm guessing taking a wheel position and then applying I think I need to do this for all the wheels actually. We'll go through each of the wheels and compare the force at them. How do I convert the apply rigid body angular velocity? How do I apply the rigid body angular velocity? Doesn't say anything about how you can convert this vector 3 angular velocity to quaternion. Beyond black belt 4th degree, I don't teach children. People come to me to get promoted after their black belt. Ah. Beyond Black Belt 4-3. So I guess that answers there is something after Black Belt. Oh. I don't know.
From Moscow to the great Mississippi, so I reckon in 21 seconds I'm about to blow this thing straight to the heavens. Still stressing, still second guessing, paid my price but learned no lesson. You got that something I need, everything that makes
Apply angular velocity.
you see deeper. You put your arms around me, yeah, shielding me from everything that could ever hurt me. Yeah, baby, you got that something makes me feel like nothing can break me. Yes, it's true, your loving keeps me in. Honey, you got that something that is real.
So I actually need the local wheel position, or I'm wondering if I do on collision enter and on collision stay, if I can actually process the collision there, because I think that would actually make more sense. Then I could add like artificial friction, or let me think about this. What if I just add the friction to everything and then I just apply way more forward velocity? So now it doesn't move because there's not enough force applied. I'm outlearned in karate. It's after 5th degree they become headmaster of a single dojo. Is there something bigger than a single dojo, having multiple dojos? Okay, interesting. So the high friction is actually bad because it creates this effect of the car raising up in the air. What the difference between static and dynamic friction? Interesting, it's kind of working. Okay, that is why we need anti-roll bars. I want to progress any longer because I'm happy where I'm at. That's good. So I might need anti-roll bars here. I just don't know how. Let me try Googling. Okay, so we apply some anti-roll force. How generally does this work? Real cars have stabilizer bars. Link the two wheels on the same axle, allowing a limited degree of freedom between them. When one of the wheels is pushed upwards, stabilizer bar transfers a portion of that compression force to the other wheel so its suspension compresses as well. Limits the roll. Interesting. Interesting. Each degree in karate is called a dan. I am at top of the progressions where you learn new stuff, so I can't learn anything new. Well, I guess you can't progress then. I could progress into new dojos, but I don't want to. So is that like re-rolling? So it doesn't turn. No, yeah, so the static and dynamic friction do not work well. Fair enough. It's actually kind of weird how, like, it doesn't turn. I guess it makes sense, though, with the way the friction works. Yeah, this is interesting though. With no real friction, there's no flipping, which actually is kind of good in a way. I was thinking, how would I calculate the friction? Still, I guess I can look at applying the angular velocity. Anti-roll bars work by transferring the compression force from one spring to the opposite on the same axle. The amount of transfer force depends on the difference in suspension travel along the wheels. Calculate suspension travel as well as determine whether it's grounded or not. Fully compressed, fully extended. Inverse transform point, hit dot y. I don't know how that gives the... Like it's the Y position. That might not work if you have the car flipping or whatever.
It's in your head and you want it out. A broken mind, a shadow lost within. Suddenly you feel it on your skin, and you know that it won't let go. And it won't let go. And it won't let go. And it won't let go.
Okay, interesting. I almost feel like trying to set this up with the actual Unity wheel colliders, but I just have had so many issues with the wheel colliders jittering.
It's in your head and you want it out. A broken mind, a shadow lost within. Suddenly you feel it on your skin, and you know that it won't let go.
Yeah, I really want to try to get custom control. I'm still gonna do these anti-roll bars, but I'm not gonna use the wheel colliders. I'm just wondering, how do I calculate the sideways velocity? I guess maybe I'll try debugging and printing that out. I'm just also thinking, like, on collision enter is probably a good way of doing this. I'm gonna try on collision enter and on collision stay. Such parameter has to be of type collision. Oh, is it just a single collision? Alright, so now I think I need to save the last force. Alright, so then we can check the friction with the dot product between this last direction and the collision. Oh wait, we have to loop through all the contacts. Use get contact or get contacts instead. Normal point separation, the distance between the colliders at the contact point. I think what I'm looking for is velocity. Friction force sum. Relative velocity. Impulse. The total impulse applied to this contact pair to resolve the collision. I think this is what I'm looking for. So how do I apply this here? I guess the relative velocity is kind of what matters. Now, should I just apply force for each of these? This still doesn't give me the sideways direction that I need to apply to get friction. Yeah, I actually think I need to do this manually for each wheel here, because this still doesn't give me the value I'm thinking of. That's how much the wheels are like swinging around, or basically how much the angular velocity converts to spatial. So how would I convert these wheels to local, because this is scaled. So what I think I need to actually do is do world position minus this equals the body position. And then we can apply the quaternion here. How do I apply this, though? How do I convert this vec3 angular velocity to quaternion? So I guess angle axis or axis angle is how we do this. And then we do val.magnitude, and then we normalize this, I think. Okay, so we need to calculate this is complicated. This is some complicated math right here. So we need to calculate the direction angular velocity is always so hard to deal with. So I'm just thinking, I think I just need the direction here, which means I can multiply this by a very small amount. I think, hopefully. So let's get the difference in movement. The delta between these two. Actually, so we have to get this relative as a force. I guess I could just take this and project the linear velocity from the angular. So like just multiply this by no, actually that won't work. That needs to have the magnitude included. The difference of those, and then I think I also need to add so this needs to be the force it's traveling at. which also includes the body velocity. Yeah, I feel like I should probably scale down this magnitude and then scale down this to compensate for that, because these are going to give me some crazy rotation values, I think, and that's going to make this inaccurate. I'm just thinking, I guess I can normalize this now. I guess I actually can scale this by a small value so that I can hopefully get higher precision out of this. I'll try both, actually. Alright, so now that we have this gives us the direction that the object is traveling at. So you can also measure the magnitude like this. So I guess I will just add force. But what way will my friction angle be? I'm just thinking if velocity change is exactly what I want to do for this. So if this is equal to friction, we gotta flip this to negative again. Let's see if this works. Okay, interesting. It sends it flying. So what's going on here? Friction. Negative. So if this is equal to friction, then it's headed in the wrong direction. So it applies this. Velocity change ignoring its mass. This has the velocity included. Yeah, I feel like it's the angle axis right here not working properly. Damn. Interesting. So it's kind of actually working, but it's way too strong. Huh. Oh, this is being applied to the wrong thing. Or wrong position. That could explain a lot. Interesting, it's swinging back and forth now. I have a feeling this is still going to be way too strong. Yeah. Yeah, it applies way too much force. I'm almost wondering about just calculating the angular velocity. Interesting. Seems to work decently moving forward. Or not. Yeah, I feel like most of my problems come from this not being able to get the angular velocity properly. I feel like this angular velocity vector that Unity gives you isn't actually accurate. Or it can't be converted to quaternions, I guess. I think it definitely should be able to be converted to quaternions like this, but it does not seem to be lining up with the actual rotation. Alright. What other approaches can we try? Yeah, like how would I track the sideways friction? I actually wonder if on collision enter is the way to do it and just like limit sideways friction. But then that would obviously make the car flip way more. Isn't angular velocity in Euler degrees? It's in radians in Unity. Which, so that's, yeah, in radians per second. And so then the angle here, oh my god, you're actually right. You're actually somewhat right. I don't think it'll fix it, but you're right in that the angle axis here takes degrees. You're right and you're wrong. The angular velocity is in radians, but I didn't realize that this angle axis takes degrees, which is different than radians. You're normalizing radius per second as an axis. Yeah, that's the thing. It is an axis still. That is the thing that really is like the angular velocity vector. So as far as I'm aware, the magnitude of this is the radians per second, and the normalized vector is the axis. Angular velocity is the rotation axis, normalized multiplied by the speed in radians. No, it doesn't use pitch and yaw. That's not how you can't. Pitch and yaw doesn't work for like advanced physics. I was right and I was wrong. The angle axis isn't in radians, it's supposed to be in degrees. But that won't change it, because I still was barely using the magnitude anyways. It's mostly based off of just the direction. That's so weird. And now it applies opposite rotation. Yeah, so this is also weird. I don't know if you see how it spins around faster at one point than the other. See how that works? Like the rotation is uneven. It almost makes me think it's feeding me an incorrect vector, like the way the rotation is unequal. I really feel like this isn't... I kind of think that isn't angle axis, and that this post is incorrect. It's really annoying that Unity doesn't document this at all. Like, at all. Rotate by angular velocity. Add the angular velocity to your object's rotation. Inverse transform vector, angular velocity. What the hell is this doing? Inverse transform vector, angular velocity, rad to degrees. Inverse transform vector.
That made me feel good. I must say I question your motives.
Yeah, the inverse transform vector will convert this from world to local angular velocity. This is weird, because that says that the angular velocity is almost like an actual world vector, like that. What? I think none of these answers on the Unity forums are correct. Okay, let's try this. I don't think it's gonna work, but might as well try, right? No, I actually think it does the same thing as before. Actually, it might be a little bit different. Either way, it is not working. Yep, doesn't work. Disappointing. Alright. Try adding a little bit of friction. I was thinking, how could I add sideways friction effectively? That's interesting. Even a little bit of the friction ends up messing with like the turning. Yeah, so even a little bit of the friction messes stuff up. I might end up just trying to use the wheel colliders. Oh, I'm really avoiding this though because I've seen so many bugs with the wheel colliders. And I feel like getting to, I don't know, control like the driving just manually, you can do so many more cool things. And control things like when it slips and things like that. See, what I need is I need like a way to control friction on like individual parts of the object. I'm almost thinking if there's a way to do it with on collision, because then that just gives me each point that's hitting. It would still be doing the same thing as the raycasts though. I need to calculate how much sideways force to apply. What I also think I need to do is I need to convert the existing momentum to forward movement. Man, cars are difficult. I guess I could try this without the angular velocity. I feel like it still won't work even without the angular velocity. Yep, nope, so going forward spins it. Huh. I'm just thinking, like, what if I almost take a realistic approach where I track each of the raycast points and, like, basically, what if I try to simulate, like, wheel velocity just from the raycast points? I'm thinking that would actually mean tracking the collider on collider enter and stay, though. Because right here it doesn't give me any individual force responses. I'm also thinking the on collider enter will probably have the rotation velocity already integrated as relative velocity. Hold on, I'll be right back. I'm gonna go get some water. Think about this.
Take me onto the stars, 'cause I'm very back in our past. So close, but ever so far. Give me at it. Remember the truth, without hesitation. Every little bit of way back to the start. Such a new sensation. Never thought it was over. You are all I could think of. And I don't wanna move on. If time is a healer, and I want it forever. Take it for a while. Rewind everything if I could. Nowhere wrong or understood. Give me at it, oblivion. Take me onto the stars. Very back in our
Man, this is pretty complicated. I was thinking about, what... So, like, doing the adding the friction via force there is the proper way to do it. Like, if you're actually building a physics engine, you apply the friction as a tangent force. But I can't do that here because I'm not, like, hooked into the physics engine. So that's kind of disappointing. So I think I'm gonna need to do, like, an arcadey, sort of hacky way of doing the physics. Or, like, that's my thing, is I don't even necessarily need real physics. I just want it to, like, feel like a car. So I'm almost thinking of what I was doing in, the little spaceship game I was trying out, where I was resetting the angular velocity. But what I'm thinking about is, so if you have both wheels on the ground, it'll limit the angular velocity. If you just have one wheel on the ground, then it won't limit the angular velocity as much. I don't know. I'm almost thinking of applying the grounded force afterwards. So then if grounded, we'll set the angular velocity to 0, or we'll scale it down massively. Alright, interesting. So now it can't turn because there's no angular velocity. So that's actually pretty good. So this means we'll now do turning via our own angular... I don't know if I'd say our own angular velocity, but like... Technically, this should be applying a little bit of angular velocity. Well, I guess I'll try just scaling it back. So now I just need to add a way to turn. I'm thinking about doing turning as the angular velocity, because I can't really think of any other way to do it, because if you don't use the physics engine for turning, it'll just like put the object inside another object. So I kind of need to use angular velocity. But I think what I'll do is add torque. I guess I could set the angular velocity here. So I guess I just want to rotate it around vector 3.up. Let's see if that works. So now I should be able to... Oh my god. So this is really bad, in a sense, but this is also really good, because this is like us having full control over all of the movements. This basically means that we can control how it turns, when it turns. So I can actually also limit the sideways movement by reapplying the force forward. Actually, the same thing I did with the spaceship. Alright, we're actually a step closer to having a vehicle. Oh no, we fell. We are a step closer to having a vehicle. I'm just realizing there is a... This directional light I have here doesn't set the Unity directional light. So what if we set this? Nice, okay. So now our sky actually matches. Alright, so if we take the velocity and we scale it back by like 0.1, I guess however much we want each frame, then we apply the same, we apply the force we take out of here back as movement force. Alright, so how do I do this? If we're applying a scale of like 0.99, I guess I take the velocity that is taken away from here. So then I think F scale times equals 1 minus V time times eval dot magnitude. So this will actually might need to do this the opposite way. So if this scales back by say 0.9, it would remove 0.1. So the 0.1, 1 minus 0.9 will end up being 0.1. But it ends up scaling by 0.1, it'll remove 0.9. So yeah, this should work. So now this should basically redirect... Oh. Never mind, it's broken. I was going to say it should redirect any movements to forward or backwards, but it's only letting you move sideways now. Which means that it is broken. Oh my god. It is actually somewhat working. It's not the best vehicle, but it is actually a vehicle. It seems like it's limiting the velocity. Yeah, there's something applying friction. Oh, yeah, okay, so this is actually really good. So this is just applying constant friction, and now we need to actually apply the friction based off the direction. So how would I decrease it? I like how this has way more control over the driving now. I should maybe add some graphics soon so it's not just black and white. I'm really focusing on the car mechanics though. That's kind of drifting right there. It's drifting too much though. I should still add a little bit of angular velocity too. Like maybe interpolate between these. Floor texture interference FPS. Yeah, the floor texture is not great for moving quickly. Oh, no, it's stuck. I'm just thinking, how am I going to calculate if velocity is being applied sideways? Like if there's sideways friction. If you move fast along texture like this, at some speed it will move backwards, you know. Yeah, it'll switch between moving backwards and forwards. Yes, the Nyquist limit. Yeah, I'm not really worried about the ground looking nice at this point. I honestly think I'm pretty stuck at this point. I haven't really made much progress. What is this purple thing? What is this purple? Is this the main camera? What is this purple icon here? I'm actually confused. Which one is that? What, like... It's obviously something under the main camera. What is this purple box? Wait, what? The property volume is being displayed? If not global, how do I check? Oh. If not global and not camera data. I made a mistake in my code. That's what that purple object was. That makes sense. I guess I could literally calculate sideways as like... Huh, no, it has to be your wheel direction. I'm thinking about it, it has to be the wheel direction. And this angular velocity needs to be based off your movement. A car can't just rotate around in place like this. Alright, I think I'm pretty happy with this as a base. Like, everything is working. Or not everything is working, but like, I have a solid foundation down now of how I want to do this. Just simulating what it's like to, like, control a car. I'm just gonna make this change to this code as well, so it's consistent. Not global, and is camera data. There we go. Everything is working. Rare and Unity, ultra rare. I mean, not everything honestly, barely anything I've tried to do today has worked. Did you see, I guess you weren't here when I tried to do wheel colliders. So I started by trying to do wheel colliders, because it's like, why would I make a car in Unity when they have a vehicle system built in with wheel colliders? So, hold on. I tried to do that. I set up some simple wheels. Let me try to... Okay, here we go. So I set this up. This is a wheel collider on the square or rectangle that I have. So I was like, alright, let's just put 4 wheels. I followed the wheel collider tutorial. Anyways, so put wheels on. I didn't even start doing the driving. I put 4 wheels on. Where is it? Okay, here we go. You can actually see at the beginning here. I put 4 wheels on, or I put 2 wheels on, and you see it just shakes. It's unstable. Instead of balancing on 2 wheels, it shakes back and forth and constantly rotates. So that was with 2 wheels, and I was like, okay, maybe it's because I put 2 wheels, and it's not designed for that. So then I added 4 wheels. Alright, so now with four wheels, it leans over. Look at this. This is where it drove me crazy.
Pretty buggy.
Like, I'm dumbfounded why it's tilted over sideways. I'm looking at the wheels like, are the wheels not aligned?
I can't see any reason why this would be uneven like
Look at this. Look at this. The wheels are even. The wheels are even on each side. It's kind of hard to see, but the wheels are even on each side. And it's tilting over sideways, more on one side. More on one side. So, I said, like, I've had experience. I've tried to use the wheel colliders before and had basically this exact same thing happen. And I was just like, yeah, I'm not dealing with Unity shit today. So I just started doing a custom arcade like driving using just a box collider. Because if it works, then it just works, right? Like, I'm not going for realistic driving physics. I'm just going for like little arcade toy car type thing. But yeah, that's kind of disappointing. It's like I've said this many times. The reason I use Unity is so that I can just do stuff out of the box, like just put a wheel on a car and have it work. It's so disappointing to have that, like, you go into Unity and you're like, I'm gonna make a car and put wheels on it, and you put wheel colliders on, and your frickin' car flies up into the middle of space, because who the fuck knows how the physics engine actually works. It's like, oh god. It is not at all a good experience for, like, what I try to use Unity for. But the nice thing is doing a custom driving system like this, or making a box collider feel like a car, this could be easily applied in way more situations, and you have way more control over how it drives, and like stuff like how much drag there is, and like having the drag work perfectly smoothly. Okay, let me at least do this. So this is based off, the turning is based off the velocity magnitude. Actually, wait a minute. Then if it's not going straight, it's still going to be turning. Huh. Let's try it. Alright, this is probably going to turn way too fast. Kind of. Issue is I actually have the drag too high. The thing is, I need to make this drag actually be based off sideways force. Alright, so this car kind of drifts. Son shader toy. Fully working car physics with four wheels. That crazy. If I need raw car physics without physics engine, I know where to look. Yeah, that's funny, because I was actually thinking, I know how the vertlet systems like that work, and I was thinking, like, man, it would almost be easier for me to just design this out of a bunch of spheres hooked together in a little vertlet particle system. This is honestly feeling not too bad right now, though. It's just the, like, drifting is obviously... The friction and drifting is completely unrealistic and off. It's... I'm not gonna lie, though, it's fun just going over this ramp over and over again and, like, spinning around. Wee! Alright, I'm gonna change some input settings. Because I think, yeah, I'm gonna turn the sensitivity up to like 1000. Because I want these to respond basically instantly. Brain distracted equals fun. Yeah, I guess so. I mean, I don't know if it's distracted. I'm still thinking about how the physics is going to work. What just... Okay. There's something about the physics, though, where it's like top heavy in this, and when you hit the ramp, it keeps the nose of the... or it brings the end of the car up. Huh. So I wonder how I would make this... I wonder how I would keep the nose down when you go up that jump. What if we add a little bit of friction now? Didn't seem to do anything. Might have made me go up the jump slower. Oh yeah, definitely affects doing jump there. I'm also thinking if there's like, is there a better way of doing this as like an actual physics, implemented to the actual physics system? Like I'm thinking instead of doing a raycast from each of the wheels, I'm thinking what if I just track the collisions all along the bottom of the box or whatever shape, and then I like subdivide it. So like the wheels are almost the whole quadrants of each side, so that way it can apply the wheel force wherever it collides, and that way you could actually have the wheels as like actual physics contacts that align to the actual shape. I don't know. I'm kind of out of ideas for now. I think I'm going to think about this more. I started comparing the... Oh, wrong screen. I started comparing this to when I was doing that little spaceship game that I was trying to get working in VR. I did something similar to this where I did like a custom velocity and movement system for the ship. And so I'm feeling like I can do a similar thing for here. And I think that would be really nice, because then I could potentially do, like... I should actually look at the spaceship controller script. I actually should be able to make a controller like this that works for both cars and, like, spaceships. Like, it's basically the same thing of just controlling pitch in one direction and yaw in the other. Or I guess for the car, it's just yaw. And then moving it in the direction of that. I should just work on getting a simple arcade car physics working, though. Alright. That was it for today. I'm just messing around with Unity. I'm trying to, I don't know, figure out how to do certain things in the engine. It bugs me that I can't figure out how to do stuff like get a basic car working. At the same time, though, I don't feel like that's completely my fault when the wheel colliders make the rigid body fly up into space, but yeah, still a pretty good learning session today, I think. Thank you for watching. I hope you enjoyed the stream. I'll hopefully see you around. I hope you have a good day, good afternoon, wherever you are. Bye-bye. Thanks for watching. I'll probably be streaming again tomorrow, or maybe tonight. I don't know. I've been trying to still stream at least once every day. It's going alright. I think I'm getting better at I mean, what's a stream schedule? But I think I'm getting better at streaming more consistently. It's so weird, like, I stopped streaming for like 3 months, but then it's just like, well, let's just start streaming again. But the consistency is really key, so it's like, it is weird doing that. Anyways, I'll see everyone around. Bye-bye.